Alright, back with 11.2, but this time Swyk number 2. So, continuing on our path, getting more complicated with our equations. Let's see what's going on here. So, I decided to get the common denominator. I used that strategy, which I looked at the denominators. This is the only one that didn't have x minus 1, so I multiplied the top and bottom of that fraction by x minus 1. And then you can see I multiplied x minus 1 times the whole thing right there. And so let's see, got rid of all of those denominators. And that left me with x minus 2 equals negative 1. And of course we're going to distribute that. Start adding some like terms on that side. And then start moving some things around, right? We added the 5x to that side. We added the 2 to this side. So 6 equals 6, x equals 1. Sounds great. Looks normal, with one major problem. When you go to plug it back in, what's happening? What's going on here? Look at those denominators. 1 minus 1, 1 minus 1. Wait a sec, I thought that was 0. Can you have 0 in the denominator of a fraction? No. Don't do it. Don't do it. That's a felony in most countries of the world. In fact, all of them. Except in English class. You get away with all kinds of stuff in English class. No, your answer is right too. Sorry. I digress. My answers were always wrong in English class. There were like 7 other kids that had answers which were possibly correct, but not mine. Alright, that's why I became a math teacher. So, there's no answer to this question. The only possible answer we found did not make the equation true. No solution. Don't waste your time once you realize that. No solution. Circle it and move on. Question 7. So you notice that this one had a little bit more work involved. What I did was I asked myself this question. To try to build a least common denominator, right? The LCD here is p times p plus 2. And there's no reason you should distribute that. That's a waste of your time. So what was the first denominator missing? It was missing a p plus 2. What was the second denominator missing? It was missing a p. Now don't sit there and try to argue with me and say, well, isn't it just missing a plus 2? No. P and p plus 2 are completely separate factors. Don't try to say that they're, somehow like each other. That's like saying 2 and 3. They're next to each other on the number line. Therefore, they must have something in common. They don't. Okay? And the last denominator was missing both p and p plus 2. So, if it's missing something, you have to multiply the top and bottom by that value. Now, p and p plus 2 get multiplied times the whole thing, and then beautiful things happen, right? All that stuff's gone. Now, keep in mind, if I get an answer of 0 or negative 2, I will have to throw them out. Now, if you don't understand why, set the factors in the denominator not equal to 0 and solve them. Well, one's easy. And the other one is where I get the negative 2 from. So, if those numbers show up, I have to toss them. Okay? They're called restrictions on the denominator. So, okay, back up here. So I ended up having to distribute, right? The 15 gets distributed to the p and the 2. The p gets distributed to those 2. The 6p gets distributed to those 2. What do we end up with when we do all that distributing? We end up with this. Sorry. If you take away the 6p squared from both sides, boom, that's gone. All right. Then you got 15p minus 5p, that's 10p. And you got the 12p over there. And 30. And then so I'm going to bring this to the other side and get 2p divided by 2. P equals 15. Well, that's not 0 or negative 2. Now, could I plug it back in and check to see if I make sure I get the same number on both sides? Yes, I could. Okay. I know it says check the solution, but man, that'd be a lot of work. Yeah, it might not be as bad as you think. Let me pause for station identification. This is the All Algebra 2 network. Well, hey, look at that. Plugged in 15, ended up getting this and this being 1 plus 5. It does add up to 6. It works. Nice. Okay, so this problem, you could see in the first fraction, it had an x minus 1 in a denominator. Whoops. But it was missing an x plus 1, so I had to add that to the top and bottom. Second one had an x plus 1, but it was missing an x minus 1, so I had to add that to the top and bottom. The last one, right, x squared minus 1, when you factor it, has both of the linear factors. I didn't have to do anything to that. So then I decided to multiply everything by the common denominator, which gets rid of all those beautiful denominators and leaves me with something nice. So you've got 1 times x plus 1. Now, never say at a party, distribute the 1. Okay, you'll get kicked out of the party so fast, I'm just telling you. Okay, now do pay attention to something on this next one. Notice that I'm circling the plus with the 1, and, although I wouldn't want you to say distribute the 1 at a party, the reason I'm pointing that out is sometimes the problem has subtraction in it. In other words, that sign, instead of being addition, could be a minus for subtraction. And then that would become a negative 1, which would distribute. And that would make a difference. Okay? I'm just trying to point that out. Obviously, it's not going to make a difference this time, because you're just going to get your x minus 1. So then you can add those two things together and get the 2x. The 1s are going to cancel out, right? And then you can just divide by 2 and you get a 1. Wait a second, that causes a problem right there. 1 minus 1 is 0 in the denominator. Ain't gonna happen. No solution. Moving on. Okay, if you take a look at this one right here, you could see that the denominator, I factored the r squared plus 3r minus 28 into r plus 7 and r minus 4. Then I started to go through and say, okay, what's this denominator missing that the other one has? Well, this one was missing an r minus 4, this one was missing an r plus 7. So, of course, I did the whole top and bottom thing. Now they all have the same denominator. I can multiply by r minus 4, r plus 7. Get rid of all those denominators. So then I can focus on the numerators, right? So you've got 2r minus 2 plus 2 times r minus 4, which is 2r minus 8. Maybe I should zoom out a little bit so you can see more. Equals 2 times r, you're doing this whole distributing thing. And, I should probably go with a different color. Well, so I could start adding like terms. Those are like terms, those are like terms. And then I could start moving things from one side to the other. Subtracting a 2r, adding a 10. And so we ended up with 2r equals 24, divided by 2, and you get 12. 12 doesn't cause any major problems when you plug it back in. It would be the same on both sides, so we're good to go there. 12 is your final answer. So, lots of factoring here. The first one factored into x plus 3, x plus 5, x minus 3. The next one was x plus 4, x minus 3. The last one, x plus 4, x plus 5. Now, I started noticing what they were missing. Yeah, so the first one was missing the x plus 4. The second one was missing the x plus 5. So remember, you got to multiply top and bottom by that. The last one was missing an x minus 3. Then, of course, you're going to multiply by all that stuff. So all of this stuff is going to cancel with all those denominators gone. Okay, then you got to focus on your numerators, right? 4 times x plus 4. distribute this stuff, distribute this stuff, distribute this stuff. And when you do that, you get all this stuff. And you can start to add the terms together, right? The 4x and 4x is 8x. 16 and 20 adds up to 36. And then you can move things to the other side. So 3x gets moved to this side, minus 36 gets moved to the other side. We ended up with 5x equals negative 45. And then you can divide by 5 and get negative 9. Negative 9 would not cause a problem if you plug it in. And you can take that calculator and double check, going through the problem and plugging in negative 9 to every single x value in the original problem to see if it works. It will. I know it will. What I'm really looking for are those denominators. Those problems where the denominators, like you couldn't have a negative 4, right? Because that this factor right here would not let me use negative 4. You couldn't have a negative 5, and you couldn't have a positive 3. Those are the main ones we were looking for. Anyway, talk to you later. Have a good day.